welcome back to the session. We are Dr. Miyadera, are you there? Yes, sir. You can start up with your presentation. This is Dr. Miyadera will be delivering his presentation on mathematical games of dice, research-based calculations using computer algebra systems. Over to you, sir.
Can you hear me?
Yes.
Yes,
I'm going to. Thank you. We are Ryohei Miyadera, Akira Murakami, Nazuki Terakawa, Keito Tanemura, Mao Fujino, Hisashi Sakahira, and Masanori Fukui. We are from Japan, and we are quite a unique group. Two of us are researchers, and others are high school students. And we are going to talk about mathematical game of dice. And what we are going to talk is very simple and interesting mathematical fact. This is a new fact discovered by calculation of computers. But because there is a very long history of elementary probability theory, it's very difficult to decide it is really true or not. We consulted some mathematicians who study probability, and they didn't know this fact at all. And I think this is a quite good exercise problem for junior high and high school and undergraduate elementary probability theory. This is overview of this talk. Background, the start of this research, how to make variant, and prospect. Now I'm going to talk about the game itself. This is very important definition. There are two players. Players A throws 3 standard 6-face dice, and player B throws 20-face die. And the winner is a player whose sum of dice is higher than that of another player, who has a better probability of winning. If you calculate the probability, you will find that they are even. I mean, they have the same probability of winning. Calculation is not difficult, but a very important point is the average of 3 6 dice is the same as the average of 20-faced die. And the average is this one. And this fact is already known. And many people think that this is very interesting fact of elementary probability theory. And we started this research by changing conditions of original game. We study changes two parts, to change the numbers of players and to use varieties of dice. First, we change the number of players. In the original game, there are only 2 players who use 3 6-face die, and another player use 20-face die. But this time, 2 players, A1 and A2, use 3 6-face die. Then, who has a better chance of winning? If you calculate the probability, you will find that player B with 6-face die has a better chance. And almost same thing can be said about there are 2 players with 20 die, face die, against one player with 3 6 face die. So it seems that players with 20 face die have an advantage when the number of players are more than 2. Then what we can do next? We make the number of players bigger. So this is the case between quite a many players, A1, A2, AN, who use 3 6 face dice, and against player B, who use a 20 face die. If you calculate the probability, player B with 20 face die has quite a big advantage. These are calculations. I skip the data. And same thing can be said about this case. There are many players, and player A has 3 6 dice, and player B1, B2, BN uses 20 face die. These are calculations. Then we can change the shape of dice, and we can use varieties of dice. Now we study the case with 19 face die. Of course, you cannot make this kind of die in real world, but in mathematics, you can define a random variable whose value is 1 to 19, and the probability is the same for value. So instead of 20 face die, if you use 90 face die, and the number of players are quite big, then you have almost same result. These are calculations. I omit that. How about 18 face die? And you have almost the same result. When there are many players, player with 18 face die have advantages. These are calculations. And next, we use 17 face die. And if you calculate the probability with computer, you will find a very different and, in a sense, very strange result. This one, I'm going to talk about this a little bit precisely. No, this one and this one. Okay. So in this case, there are many players who use 17 face die against player with ordinary dice. Then the advantage of 70 face die became at first it continues decreasing until n equal to 16, then begin to increase. Okay. So what I discovered is a very strange fact. In summary, if we use if there are only two players, then and the average of the dice are the same, then the probability of winning is same for two. But uh, if there are many players, the probability become uh, very complicated. And the advantage of players, if you calculate them, you can find a very, very strange fact. If you generalize the result, you can get this kind of formula. And this is uh, very not difficult formula to prove. And I'm going to talk about the important point of my research. Uh, this is a very simple and elementary mathematics. And usually in mathematics, it's very difficult to find new things in elementary area. But with the use of computer, you can discover new things, even in an area where uh, everyone thinks that there is
Professor,
nothing
you
to
are
say.
requested to please wind up. We are running up short of time.
Okay.
You have your second
Right.
presentation as well.
Thank you. I finished my talk. Thank you.